Let's take a look at operations on functions. So we've talked a little bit about how we could say y equals 2x plus 3 would be the same as if we said f of x equals 2x plus 3. This then would be our function notation, right? This whole f of x. But we're not stuck to just the variables f and x. We could also say, g of t equals 2t plus 3. All of this is talking about the same thing. It's just different ways of stating it. So we're going to now work with operations using this function notation. So instead of having things all by themselves, now we're going to say, okay, take f of x and add it to g of x, or take, f of g of x. So we're going to work within this function notation a little bit. So let's take a look at an example. Let's say that we are given f of x equals x plus 2 and g of x that equals 5x minus 1. Let's say we are asked to find f of x plus g of x. All right, so all I'm going to do is I'm going to take f of x and replace it with what it's worth. So f of x is worth x minus 2, x plus 2. So we have x plus 2. Then we're going to take g of x and replace it with what it's worth, which is 5x minus 1. And we'll add them together and see what we get. We know we're going to get f of x plus g of x, but we'd like to have a little bit more information there. So I'm starting out with x plus 2. Nothing changes, so I can just drop those parentheses. Here, though, I'm distributing a positive. When we distribute a positive, it does not really change anything because a positive times a positive x is still positive x, whether it's a 5x or a 7x or a 10x, whatever. A positive times a negative 1 will give me a negative 1, so that negative sign stays intact. So now let's just combine like terms. So I have x plus 5x, which is 6x. I have a positive 2 minus 1, which is a positive 1. And there's no more that I can do with this. So f of x plus g of x can be reduced down to 6x plus 1, but no further, because I don't have like terms to combine. Let's see what something maybe a little bit more complex would do. Let's say that this time, instead of addition, we're dealing with subtraction. So we have f of x equals 2x plus 2. And g of x equals 4x minus 1. And we are asked to find g of x minus f of x. So we'll replace g of x with what it's worth, which is 4x minus 1. And we will replace f of x with what it's worth, which is 2x plus 2. and we're going to find their difference. So again, in these first parentheses, nothing changes, so I can just rewrite it without the parentheses. But in this next set of parentheses, I have distributive property. Negative times 2x is a negative 2x. Negative times a positive 2 is a negative 2. Notice that both signs changed. Negative times a positive is a negative. Negative times a positive is a negative. Now let's combine like terms. We have 4x minus 2x, which is 2x. We have a negative 1 minus 2, which is a negative 3. So what we know is that g of x minus f of x equals 2x minus 3. Let's keep going and see what happens when we have a value given to us. So let's look at